Hello, everyone, and welcome to the Scaling Ethereum 2024 Avail Workshop, Avail 101. Joining us today is Robin Roy, who will be taking us through this session. And with that, I'll pass over to Robin to get the session started.
Yeah, everyone. Hope you guys are all settling in. I'll just give a. I'll just wait until a couple more people joining before we start. Alrighty, then I think we'll just get started. Hope you guys can all see my screen. Awesome. Yeah. Hello everyone. Welcome to this Avail 101 workshop. We are one of the sponsors for ETH Global Scaling Ethereum Hackathon. We're happy to be here and meet you all. Um, so just to get a quick uh, census on this, how many of you have already heard about Avail or know about Avail or about its workings, inner workings, or at least just know about Avail? You can just drop it in the chat. Okay, there's some folks who know that it's DA layer. Okay, awesome. Yeah, so essentially, Avail is, you're right, Avail is more than just a DA layer. Avail has essentially three products lined up, and one of it is the DA layer called Avail DA. So we'll delve more into what all of that means. We'll dive into exactly what will be relevant for the hackathon itself and what Avail is planning to do in the near future as well, right? So, right. So, what to expect during this workshop? I'll give you a quick introduction on the Avail Trinity or Avail DA execution, which is what we call as the permissionless unification layer. And I'll delve into why we call Avail a permissionless unification layer. We'll go into Avail DA and its architecture to help you understand what we're doing, and then we look at some of the explorers, tools, how can you interact with the Avail network and more, right? And then if time is there, we can do a Q&A session as well. So let's give you the big picture here. So obviously, I think we are trying to scale Ethereum here, right? So even at this hackathon, what we're trying to do is we're trying to scale Ethereum, and one of the major ways that Ethereum's roadmap has been moving towards is a roll-up centric roadmap. So for Ethereum, roll-ups have taken the center stage, and what that means is now we are kind of decoupling execution from settlement and data availability. And Avail DA is attempting to decouple data availability from Ethereum so that you have cheap DA, you have secure DA, and also you're able to have some extra perks that Ethereum does not have currently, but is in the roadmap for the next 5 years, like KCG commitments, database sampling, etc., which Avail provides already today. So Avail DA is essentially born out of the need of cheap and effective DA, while because like even though there is AI before 844 that recently launched, we've got blobs on Ethereum mainnet, it is still expensive for the average user on rollups. Even though the costs have cut down, it is not as low as we would like it to be, right? So essentially, there is still a need post DIP 4844 that there is a need for cheap and effective DA and other security guarantees that come along with having a DA layer, right? So Avail DA is powered by erasure coding. We erasure code our blocks and have KZG commitments against them for values. So we are able to provide, you know, basically through the KZG commitments, we are able to prove that the blocks have been properly encoded and overall better UX. And we kind of predict that, there'll be hundreds and thousands of general purpose and app chains that will be appearing in the near future. And we want to kind of create this DA layer in order to facilitate that. But one thing we realized that is because there's going to be a fragmentation of user experience because of these multiple roles that have been popping up nowadays. I mean, even today, there's like maybe 10 to 20 major rollups. I think even less than 20. So at least 10 major rollups. And out of these 10 major rollups, bridging to each one separately to take part in different action, to do different interactions on them is already a hassle, right? L2 to L2 bridging is a hassle sometimes. L2 to L1, L1 to L1, it's all hard. So what what we're tackling is not only DA, we are tackling unified scalability, unified experiences, unified user experience, right? That comes through liquidity, user experience, etc. So that is why we are also building what we call Avail Nexus, which will be unifying rollups across Web3 via proof aggregation and data availability sampling. And basically, Nexus will be like this unified coordination layer or a coordination hub where we'll be able to aggregate proofs from multiple rollups and do all sorts of crazy things such as async composability, which is essentially just a way of saying that you can kind of do an action on one chain and like create a promise to another rollup. And when an action is completed on that rollup, it sends back a callback to the first rollup, right? So you're able to create composable applications, composable experiences in an asynchronous way, which is not possible today in the current architecture of rollups that we have. And that is what Avail Nexus provides. And Avail also has, because we're connecting all of these ecosystems together, we want to provide extra crypto economic guarantees to our Avail consensus layer, which is why we're also building Avail Fusion, which is going to be a way for you to stake major ecosystem tokens like Bitcoin and Ether to directly be involved in Avail's consensus. Avail basically provides, it's not only a DA layer, it's more than that. We provide Avail DA, which is going to be the root of trust for all of these applications. We have the Nexus, which is going to be a coordination rollup, ZK aggregation, proof aggregation, with shared sequences selection um, as well on Nexus, and then we have Fusion, right? Which is going to be allowing you to stake different ecosystem tokens to be part of the Avail consensus layer. So I kind of already went through this. So Avail DA, it's a validity proof-based DA layer and what you will be building for this hackathon will be directly related to Avail DA. Nexus and Fusion are still not available. It's still a work in progress, and Nexus will be ready by late 2024 and Fusion by 2025. But Avail DA is in testnet and will be going towards mainnet next month, actually in a couple of weeks, or just more than that. So in this end of this month or next month, we will be going to mainnet, right? So what you are going to be building for this hackathon will be directly related to Avail DA. So Avail DA is a powerful validity proof-based DA layer for next generation trust minimized applications. Um, uh, and basically you're able to use Avail's block space, which ultimately uses light clients for data availability sampling. We use KZG polynomial commitments to make Avail DA suitable for unifying ecosystems. And we'll delve deeper into the architecture here in just a bit. I already spoke about Nexus, but essentially what you can kind of see here is Nexus is going to be like a coordination rollup that's going to be running on top of the Avail DA layer, and it will aggregate proofs from different rollups, and you will have this kind of unifying layer that is going to be helping coordination among these different rollups, right? And we have other things that we are trying to do as well, like sequence selection on the Nexus layer as well. But yeah, I'm not going to dive deep into this right now because it's not going to be very relevant for Hackathon as well as Fusion. But if you want to read more about this, we have if you go to our blog, we have a complete detailed blog about what we're doing and what we're trying to achieve here. So essentially, Avail accelerates the unification of Web3 by enabling modular execution to scale and interoperate in a secure and trust minimized way. Um, why trust minimized? I'll get into that real soon. It's essentially because of what we call as a superpower. We have light clients which are able to, in a trust minimized way, verify, validate uh, if the block is valid itself, or if the data is being made available on Avail DA, right? So Avail DA is a modular base layer. It's a data availability layer, which provides raw block space to modular chains. That means you can run your own Validium, you can spin up your own Validium or an Optimium, or your app chain or a sovereign rollup or whatever you want on Avail DA, using Avail DA's block space as a way for you to kind of sequence, package, and publish data. Um, and the way we've structured our blocks is in such a way that it segregates the transaction data on a per rollup or per application basis. So each rollup that you build, so you can create your own application ID, and the block itself is a matrix of these application IDs. And you can just, for example, you can just mention when you're submitting this data, you can mention the app ID and then submit the data. And so when you're fetching, you don't have to download the entire block data. You can just filter through or index through for your app ID and just pull your data in case you want to do something with that transaction data or state editor that you are posting to Avail for your use case, right? So that is one of the core features that Avail has. Uh, Avail also has Avail DA also has a robust validator set of so we are able to support up to 1,000 validators on mainnet, and eventually we can even expand it to up to 10,000. Um, for the current testnet, we have limited it to 300 validators. But one thing to kind of keep in mind is that Avail DA is a DA layer by itself, so it does not have an execution layer. So that means you are not able to like to deploy smart contracts or something like that. For doing those kind of things, you need to have some kind of an execution environment built on top. So you need to deploy your own Validium, you need to deploy your own app chain or something like that to have some kind of business logic being integrated for your use case, right? Avail just acts as this bulletin board of with raw block space where you can just post data to, and Avail does not interpret that data in any way, right? So each rollup built on Avail is completely custom. You can use whatever VM you want to use. You can use a ZK VM, you can use a ZK EVM, you can use like a Move VM or a Solana VM, whatever you want to use, and you can configure it to send data to Avail to ensure that, for example, if you're optimistic in execution, you can kind of look at ensuring that watchtowers are looking at this data, and if there's any malicious transaction, you can kind of create a fault proof challenge, or for ZK proofs, you can send the data itself on Avail, you can send the proofs to Ethereum, or you can send both the proofs and the data to Avail, however you want to construct it, right? So there's a multitude of ways how you can construct these your Validium or Optimium on Avail DA. But yeah, it's completely custom and completely modular. Um, so Avail GA, like I said, has lightlines as a superpower. And what that means is we leverage KZG polynomial commitments to do data availability sampling. So what is data availability sampling? Essentially, let me see. Yeah. Okay. Yeah. I think this diagram will kind of give you a better idea on what that means, right? So lightlines, essentially what they do is they are able to form, so light lines have a P2P network. So each light line is connected to each other light line in a P2P network. They are also, and this P2P network also holds a DHT, Academy a DHT that it holds and it manages. It also connects to an RPC node or a full node as well. So what happens is the light client can sample data. So basically, if you have a full block, it can sample chunks of small data from the blocks in a randomized manner in such a way that saying, okay, for block number 100, the light client says, give me the data at this specific point. And so the full node or the DHC, if it has data, uh, will fetch that data from that particular point and give it back to the light client. And the light client verifies it against the KZG polynomial that we have. And if it checks out, it says, okay, now it goes and fetches another small chunk of the block data. And if every time you are able to verify it successfully, it means that the data is available, right? If anyone is not able to provide the data that you have randomly asked for, then that means that is that node is fault kind of, right? So this ensures that data availability is maintained, and we are able to do this because of our light client network. Um, we sample through the DHT first, and if the data is not in the DHT, you sample the RPC nodes and all of that. And another thing that we have is, because we expect Lightline P2P network is Lightline is very easy to run. It's very light on resources. We expect multiple people to run it, multiple Lightlines to be run. Imagine there's a lot of Lightlines in this P2P layer, and they're randomly sampling chunks of a particular block. There will be a point at which the entire block has been sampled at a point, and that means you are able to reconstruct the block and create a block replica. So that is what this diagram kind of shows here, right? So the light lines are able to repopulate a block replica, which means that even if the Avail network, even if it goes down, you are still able to get back whatever data was made available up to the finalized or the last finalized block, right? And you're able to fetch that data and ensure that data is made available. That is one cool feature that Avail has. I'm just going to go into this diagram as well. Yeah, so I mean, so to give you an idea on how blocks is being generated in Avail, or whatever transaction data or whatever data that is being submitted to Avail, that original data is taken, it's erased and coded, and then we create row-wise KZG commitments, and these row-wise KZG commitments are together form the block header, and which is used for what I said as data availability sampling. Um, yeah, and I'm not going to go deep into everything else here. Avail is built on top of Substrate. It by default uses Babe and Grandpa consensus, which is again something you don't have to kind of, I mean, yeah, if you're not familiar with it, it's fine. Yeah, so Babe is the block author, and Grandpa is a finality gadget. You can always look into it later. I'm not going to go deep into this consensus part right now. And using nominated proof of stake as well. 1,000 validator set can be supported, all of that good stuff. Like I said, Lightline Network is a P2P overlay network on top of the Avail network. It maintains Academia-based distributed hash table, which is why you're able to create this block replica, right? So that means the more lifelines are there in the network, the more scalable Avail gets. Yeah. So what can be built on top of Avail? Basically, you can build any kind of roll-ups, app chains, L3s, whatever. Like or if you're on Twitter, you're familiar with the debates on L3s, L4s, L5s, and all of that stuff. So yeah, I mean, Avail is, like I said, agnostic to any execution environment. You can build on Avail in very creative ways. So this is one of the ways I think you can build on Avail. So if you are building, for example, an L2 Validium, um, right? So you have a sequencer that sequences your blocks, you have a prover, all of that. You can send the data to Avail. Avail attest that data because Avail has an attestation bridge on Ethereum. So you can send the transaction data to Avail. Avail attests that the data has been included in a block and it is made available. And that proof is sent to Ethereum via the attestation bridge, and you can settle your Validium on Ethereum, right? So that is another way. That is one of the common ways you can build something on Avail. The common architecture of how you would build something on Avail. You can create L3s as well. Data submitted Avail attestation bridge says that you have the data made available. You can settle on Ethereum through the L2 protocol as well. So all of that is perfectly cool. Why would you need sovereign? So sovereign rollups can also be built on top of Avail. That means they don't settle directly on Ethereum. They have their own settling layer, and all of that is up to you how you want to build it. So what can you build during scaling Ethereum is what I want to just quickly go through. So you can build your own custom app chain or any rollup that is custom to your specific need. So you can use Madara or Rollkit. So all of these are stacks that Avail supports, and Avail has an adapter for it. You can check out our talks for that. You can also use Risk Zero. I know that they are also sponsored at the hackathon, and you can use their ZKVM to build a kind of a Validium from scratch using Avail. You can use Stackers SDK, which is very easy if you are good with JavaScript and TypeScript. You can create something like a micro rollup for your use case. You can also deploy an app, but adapt. So if you're more of a smart contract kind of a dev, you do not know much of, you are not so comfortable, or you don't want to hack on the infra side. We have set up an OP stack based Avail powered chain or rollup for you guys to deploy to, and you can deploy your dApps there. And essentially, we just want to make it super easy for you to be able to compete in this hackathon. And we've shared all of these details on the bounty page. Like if you go to our Avail's prices page on scaling Ethereum, you'll be able to find all of that, those details on how about chain information, all of that. Right. You can also try and build a liquid staking protocol for Avail. Because Avail is built on Substrate, you can build a pallet, which if you already know how to do that, it's going to be quite easy. Otherwise, you can try different methods as well. You can directly modify the node to do it, the Avail node, full node, or you can try and so we have something like the Avail web client, which directly runs in your browser, but it does not have the P2P layer connected. You can try and connect this web-like client to the P2P layer by yourself during this hackathon, which is, I think, a really cool hackathon project. Um, so in terms of the bounties that we are kind of providing, we have, like I said, an Avail powered rollup. So Avail allows anyone to spin up scalable and cheap rollups. And to showcase this, we've spun up an OP-Stack EVM compatible Avail powered chain. So this chain sends data, all of the transaction data, all of the block data to Avail directly by default. And all you can do is if you are building your dApp or whatever it is, you can deploy your smart contracts on this chain and we provided the chain information and all of the endpoints for you to connect to MetaMask to on the bounties page. We have a Notion page as well, which gives everything in detail. And yeah, you just have to deploy your contracts on this rollup, and you will be eligible for the prize or for the prize pool of $3,000. But you need to at least verify your contracts. Um, you must deploy and verify the contracts on the block Scout Explorer. You must document the contract addresses that you have deployed on the Avail powered chain, and projects. Not everyone who deploys will be eligible. Like for the pool prize, only ones that we decide are technically feasible, original, creative, and only the best ones will be awarded among this. Right. And the next one is the best app chain rollup project. So the previous one was very abstracted for you guys. So if you're an application dev, you can try that out. But if you're more into the infra side, cryptography side, things, you can try and build something directly on Avail DA or expand on Avail DA's ecosystem, right? So, like I mentioned, so this is a more bigger price per winner, I'd say, because $1,000 per winner. Um, you can try and use RISC-0 ZKVM or coprocessors to submit data to VLTA. You can use Arbitrum Orbit. So Arbitrum is also a sponsor. So we can work with them. We already have an adapter for Orbit, and you can use that to spin up your own Orbit chain and use it for whatever you want. So you can also apply for Arbitrum's track as well as Avail's track. You can use Stacker SDK, like I said, if you are familiar with JavaScript, spin up your micro rollup. You can build like an NFT marketing, NFT marketplace rollup, not marketing rollup, marketplace rollup, or on Avail DA, liquid staking for Avail, etc. And many other project ideas have been included in a cheat sheet that we provided on the prizes page. So we've included a cheat sheet. So we've listed some amazing ideas, project ideas for you to maybe try out and look at, and qualification requirements are also mentioned there. I just want to really quickly show you guys, the Explorer. So you can go to avail-testnet .subscan.io. Again, all of this is in the cheat sheet. You don't have to memorize all of this, obviously, and you will be able to find, all of the blog details. You can go to the blog and get all of the details from here. It's extrinsic in Avail terms is basically just a transaction, and yeah. So, for example, when you're submitting a data, you will. This is a transaction of someone submitting some data. Here's the fees. This is the parameters, and this is, I guess, the data that they have submitted to Avail. So this is in bytes, obviously. You can decode it if you want to. And yeah, all of this is here. And there are obviously other things that you can try out in this um, Explorer. Another thing, if you want to index Avail for some reason for your use case, we have subquery support, we have subscript support as well. So this is basically you can use GraphQL to kind of query Avail. In terms of kind of if you go to our GitHub repository, you go to /avail, you'll be able to see, you can basically run our node. This is our node, you can run our node through here. But also you notice a couple of things. We have support for um, Avail.js and sub.xt. So Avail.js is basically a way for you to interact with the Avail network directly on the network. So you can use all of the APIs that's already provided um, to interact with the network, that is to do transfers, to create application IDs, like I mentioned, or to do data submissions or whatever, right? I'll show you examples real soon. And subxt is basically the Rust version of it. It's a library where you can interact with the Rust. So if you're building with Rust, you can use the subxt library. If you're building with JavaScript or you're comfortable with that, you can use Avail.js. It's a wrapper on top of Polkadot.js. So most of the methods are similar to Polkadots. So you can refer the Polkadot documentation as well for this. and I can just show you these quick demos. I think, let me just, so I'll just show you a quick code here. So for example, if I just want to connect, right? If I just, the most basic example here is, hope you can see the VS Code on my desktop here. Yeah, so yeah, you can basically just, all you have to do is import the Avail.js SDK. That is, you just have to install it from npm, and you can import all of these things. You can create a config. I can show you the config file as well. Yeah, all you have to do is you have to replace your seed phrase, use an endpoint. Uh, if you're so when you're cloning the Avail repository, this will be by default a local endpoint. You can use the Goldberg endpoint as well. If you don't want to run your own node, it's completely fine. For example, data submission would look like this. You just have to initialize the API. If you, or yeah, if you have the seed phrase on the config, you can use this. Or yeah, you can also, I think that's the easiest way you can do it. You can add some options, and you can just call the API transaction dot data availability dot submit data, and then just submit the data here, right? And you can define it here. Sign and send the transaction, you'll be able to get the status of it when it is in the block. You will be able to iterate through the events that are being called as the transaction is executed. Um, and yeah, and you'll be able to kind of, we are able to extract the data and print that data out for you, right? So all of this is possible when you are building with Avail.js. Another thing I wanted to quickly show you is also that we have a bridge API, because I thought I saw someone asking about the bridge. Um, so like I mentioned, we have an attestation bridge. So the attestation bridge kind of allows you to communicate from Avail to Ethereum and Ethereum to Avail. And you can use this bridge API to do that communication. And you can also do token transfer. So we have implemented Avail to Ethereum and Ethereum to Avail token transfers like through this VectorX bridge, which is powered by VectorX by Succinct. So yeah, you can definitely use this and see if you need any help in using this, just let me know. But yeah, I'm just going to just stop for now because I think we are almost out of time if I'm right. So yeah, I'll just take a look at these questions real quick.
Yeah, there was a question early on. I'm not sure if you addressed it, but the question was, can you verify the data availability on ETH or any other EVM L2 using the ZKG?
Yes, so basically, you can verify that the data is made available using this bridge, right? So Whale has this VectorX. So VectorX is something that we built with Succinct. So you can basically with ZK proofs be able to kind of prove that the data is being made available on L1 Ethereum, right? From Avail to Ethereum. So we built this data attestation bridge. So whatever data you've submitted, we can attest that it has been included in the block, and if it has been included in the block, it will be made available because we've got all of these guarantees that we've got.
Okay. Then don't know if you addressed this one, but for example, we could use Avail to publish critical ZK proofs for our application so anyone could verify it. I'm thinking about healthcare data prescription.
Could you repeat that?
Yeah. So, for example, we could use Avail to publish critical ZK proofs for our application so anyone could verify it. I'm thinking about healthcare data prescription.
Um, you can create the proofs and publish it to Avail. Just want to mention that Avail is not a data storage layer. So if you want, like, if you don't compare it to something like IPFS or something, but if you want to probably use it, you know, put those data somewhere, you want to put the proof somewhere, and you want to verify it later on, yeah, you can do that with Avail. So healthcare data is pretty confidential or sensitive data. So it's a public blockchain. So I recommend you to think about how you would manage all of those kind of stuff. Um, but yeah, I mean, in theory, you could do it.
Okay, and I think you addressed this, but I'll double check. Which GitHub repo should I use as a starting point to create an L3 to Sepolia, ideally L2 Sepolia?
L3 to Sepolia. I mean, so for that you need an L2, right? So, um, I mean, okay. So if you want, you can create an L2 Sepolia if you want. So basically, you want to build an EVM rollup, if I'm not wrong, because
Kirill, actually, well, Kirill, if you want, you can take yourself off mute and ask if you're still here. Check. Hey,
Hi, yeah,
hey,
this is Kirill.
hi.
yeah.
Uh, yeah, so my question is, I'm building uh, uh, a roll-up app to have data um, labeled data for AI. So I need a lot of cheap transaction space and not too much. And I wanted to be as a L3 to another L2, like Arbitrum or Optimism or Polygon. And I'm looking for a way to do that. So taking, for example, Sepolia for base, and I want to run Avail and specify it to for the Avail L3 to be verified on Arbitrum block L2. Does that make sense?
Um, so kind of does. So I think that depends on the L2 that that you're building on, right? Do they support those L3 process? Do they have anything that can help you build that in the hackathon's time frame? Is the question I think I would ask. Otherwise, you can just directly spin up an L2 instead of like having that L3. If you really want to build it on the L3, you can. I don't really know if there is an option you can build that L3 on Arbitrum right now. You probably can. I'm probably not that much into Arbitrum. Like I don't know that much about Arbitrum, what they do, what they have in terms of allowing to build L3s at this point. But if you are using Orbit or something like that, we have an adapter that you can use to, submit whatever data you want from Arbitrum, that roll up that you're spinning up that L2 or L3 to Avail. So essentially, what this would mean is you would whatever transaction data that is being generated by these rollups will be sent to Avail. If you want to send the data itself, the training data itself to Avail, I don't think that's the perfect use case because I think you will want to fetch it and store it somewhere for long-term usage, but you can you can submit that data somewhere once, index it, and store it somewhere. But I think that's a long-winded process. But yeah, again, I probably don't understand the exact use case you're kind of mentioning or not understanding the architecture. Maybe once you can just DM me on Discord or like on the channel that set up by Global and we can
Uh,
just talk there.
okay, and what's your Discord?
Um, if you're on the ETH Global server, we have a particular channel for Avail. On that, I've already messaged. So it's actually Robin RRT, but you can
Okay,
find it directly on the server. Sorry.
okay, sounds good. Thank you.
I see a question that, okay, so looking at OPBM, where do you specify L2 and L1? I would connect Avail to. So Kirill, also on that, so for OPEVM is a project that we built that is not connected to any L1. It is a sovereign chain that lives on its own that directly just submits data, its transaction data to Avail. It's like a sovereign roll-up kind of chain, which means it's not enshrined. So enshrined chains are like the ones that are like Optimism and Arbitrum, where they have a smart contract living on Ethereum to do all of the fraud challenge proofs and all of that stuff, right? So OPEVM is separate, wherein it is a sovereign chain and a sovereign architecture apart from Avail. So if you want to use it, you're welcome to. But yeah, I mean, it's not specifically an L2. It's, you could consider it as an L1 by itself. Um, does publishing attestation to Ethereum have a transaction cost? It does. The attestation itself does cost some transaction cost to Ethereum. I mean, but yeah, that is still kind of, I think, minimal compared to like having MBs of data being posted to Avail, right? So if you consider right now, even with blobs, right, you are posting, I think Optimism is posting at least 700 kbs of data per block on like, or per blob or per block uh, at once. So in a day, I don't know how much they're doing, but probably MBs of data. And that means it's going to cost quite a lot of money. But if you just have the proof or the data attestation proof, which is very small, obviously it's going to cost much less, right? So that is different. So I see another question: why can't Avail be used in replacement IPFS? Because IPFS is implemented in a way that is content identification. You can basically use content identification. If you post some data to IPFS, you're able to retrieve that data based on a content identifier. Avail is not like that. Avail is, you post this data on this block, there you have to go back to that block hash to fetch that data back and all of that stuff. The main use case of Avail is to build rollups or validiums, wherein you can kind of post the transaction data onto this base layer, and you can use that for verification of proofs, or initiating fraud challenges, stuff like that. So it's essentially catered. It's a very niche market of being able to spin up rollups specifically. Yeah, that is the difference between data availability. I think we have a very good blog that kind of goes through this. So I can share the links to those blogs on the Discord that we have, so that it's much easier, I think, to break down the differences. Yeah.
Awesome. Cheers. Thanks everybody for the great questions. And thanks, Robin, for staying a little bit over. We do got to get ready for the next workshop, so we'll probably end it here. But thanks again, Robin, for the great workshop and presentation. And again, thank you everybody for attending and asking all these great questions. Just a reminder, we're hacking begins later today during the opening ceremony, so don't miss that. And we have another workshop in about 15 minutes. So yeah, cheers. Thanks, everybody.
Thank you all.